Section 1, 2, Irrational Numbers and Square Roots. Our objective for today is to find and estimate square roots and classify numbers as rational or irrational. The new vocabulary is perfect square, square root, irrational numbers, and real numbers. So our definitions to start, a perfect square is a number that is the square of a whole number. So if I take any whole number and square it, such as 4 squared, that result is a perfect square. So 16 is a perfect square. A square root of a number is another number that when multiplied by itself is equal to the given number. So the square root of 16 would be 4 because 4 times itself gives you 16. Irrational numbers are numbers that cannot be written in the form a over b, where a is any integer and b is any non-zero integer. Quite simply put, irrational numbers are numbers that cannot be written as a fraction. And real numbers, that is the set of rational and irrational numbers. Squaring a number. Let's start by practicing. Remember, we know that 4 squared means 4 times 4, which we all know is 16. 8 squared is 8 times 8, which we know is 64. 3/11 squared is where we have a little bit of a trick. Remember, it's times itself, so it is 3/11 times 3/11. Multiply the tops and multiply the bottoms, we get 9 over 121. Now we're just going to generate a list of perfect squares. 1 is the first perfect square, then 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. These go on and on forever. These are the first 15 in order. So the question is, where do we see perfect squares? This is quite simple. Perfect squares are the area of any square with a whole number length side. Let's find the square roots of a perfect square. There are 2 square roots of any number. 25 has the obvious square root of 5, but there's another number that when multiplied by itself makes 25, and that is -5. Since mathematicians love short ways of writing things, we can write it as plus or minus 5, and there's our answer. So now try this. Find the square roots of each of these 3 numbers. For A, 36, our answer is positive and -6. For B, 1, our answer is positive and -1. And for C, our answer is positive and -1/4. A little note, that symbol means square root. So this symbol right here, square root. If you see that symbol, it only means the positive one, unless there's a negative sign written before it. So if you see that symbol in a problem, you do not have to do the positive or negative. Now we're going to estimate a square root. The square root of 28 to the nearest integer and the nearest tenth. I'm going to start with the nearest integer. We want to figure out 28 is between what 2 perfect squares? Well, if we look at our list that we made before, we know it's between 25 and 36. It is closer to 25. So if I square root each piece of this, I know that it is between, the square root of 28 is between 5 and 6. Since 28 was closer to 25, the square root of 28 must be closer to 5. Now to the nearest tenth. This is really just going to be guess and check. So let's try 5.1. So I multiply 5.1 times itself, and I get, so I do all my work, 26.01. I'm a little low. Let's try 5.2. I get 27.04. I'm still a little low. Let's try 5.3. And here I'm just simply doing long multiplication. All right, well, we have 28.09. That is pretty darn close to 28. Whoops, so my answer is going to be 5.3 because if I took the square root of 28.09, I would get 5.3. 28.09 is pretty darn close to 28. So now try this one using those same steps we just did. You should find that 38 is between 36 and 49. So the square root of 38 is between 6 and 7. It is closer to 6. Now we want to guess and check, basically. I would go with my first guess being maybe 6.2. So I square 6.2 to see what I get. I get 38.44. That's pretty close. It's a little high, so let's see if 6.1 is any closer. This is 37.21. 38.44 is actually closer, so my estimate is going to be 6.2. And now my question is, can you take the square root of a negative number? Think about this for a second. What number times itself gives me negative 16? The answer is no, we cannot take the square root of a negative number. But one little note, if the negative is outside of the square root, we simply do the square root and then stick the negative on the answer. If the negative is inside the square root, that's when we cannot do it. Now we're going to decide which one is greater, the square root of 18 or 4.4. My method of doing this, I would square 4.4. So let's multiply 4.4 by itself. We get 19.36. So what that means is that 4.4 is equal to the square root of 19.36. 19.36 is bigger than 18, which means that 4.4 is the greater. Now the formula for surface area, that's SA is surface area, equals 13 times r squared. It's about the surface area of a sphere with a radius of r. So we are going to find the radius of a sphere with a surface area of 780. So we'll plug 780 in for SA. We're going to divide out that 13. When we divide 780 divided by 13, we are going to get 60. To undo a square, I square root. And now we'll have to use a calculator. In our calculator, the square root of 60 is about 7.7 units. All right, now when it comes to the number system, we have real numbers and we have imaginary numbers. Imaginary numbers are any of those numbers that aren't real. That's where we find like our square roots of negatives. We aren't going to worry about those for this class. The real numbers, you'll notice this line in the middle. They're divided up into rational and irrational. Those rational numbers are any number that can be written as a fraction. That includes terminating decimals, repeating decimals, integers, all of that. Irrational numbers are anything that can't be written as a fraction. These are things like pi, never repeats, never ends. This is also things like the square root of 2. We can't think of any number off the top of our head that multiplied by itself makes 2. It is irrational. So to tell if a decimal is rational or irrational, look for whether or not it terminates or repeats, but also note this. For any integer that is not a perfect square, the square root of that integer is going to be irrational. That's where my example of the square root of 2 came in. 2 is not a perfect square. The square root of 2 is not rational. Now we're simply going to classify whether or not these numbers are rational or irrational. 0.8181118111 follows a pattern, but it doesn't actually repeat. That makes it irrational. Negative 0.81 repeating. It's a repeating decimal, which means it can be written as a fraction, which means it is rational. 1 2/9. It's already written as a fraction. Straightforward, that one is rational. And the square root of 2, that's the one we just talked about. 2 is not a perfect square, so its square root makes it irrational. And here's today's assignment.